Errors are the reasons why most applications fail. If not properly handled, they can stop your program or cause it to produce unexpected behavior. In this lesson, you will learn how to effectively handle errors in your program. Let's dive in. The most common mistake for beginners learning Python is a syntax error. This happens when you don't follow Python's rules while writing code. For instance, whenever you use a for loop for iteration, a colon must end the first line before you move to the loop body. Now let's intentionally omit the colon. Let's execute the program. As you can see, a syntax error has occurred. The arrow indicates where it happened. Additionally, the error message gives you a hint about what went wrong. Syntax error expected, a colon. These errors are usually spotted by your code editor or through an extension if you are using one. The extension I'm using is already showing where something is wrong. Another syntax error is when you use the return keyword outside of a function. Return hi. Let's execute the program. It shows syntax error, return outside function. The return keyword is expected to be used in the function definition. Moving on, an exception is what occurred whenever syntactically correct Python code results in an error. This program prints the result of a division operation between two numbers. Now let's make a variable y, which is the divisor, to be 0. Execute the program again. Python raises a 0 division error when you attempt to divide by 0, which is not allowed in mathematics. The error message also indicates the file and line where the error occurred. This error occurred on line 10, which is this line of code, and this is the expression that raised the error. A Python program terminates as soon as it encounters an error. In this case, line 12, which is the last line of the program, was not executed due to the encountered error. If you know that a portion of your code may produce an error, it is important to handle such error. You can use the try except block to manage exceptions within your code. Let's include the portion that might cause an error in a try except block. We need to use the try keyword, try, followed by a colon, then press enter on the keyboard. Then the portion we want to try that might cause an error, which is this line. Now the next part is except. Then we need to mention the error that might be raised, 0 division error. Except 0 division error, followed by a colon, then press enter again on the keyboard. Print division by 0 is not allowed. You are simply telling Python to try and execute this part of the code, and if 0 division error occurs, you want to handle it in this block of code. So we are telling the users that they cannot divide by 0. Let's execute the program again to see the output. Division by 0 is not allowed, the end. Now the last line in our program runs because we've handled the 0 division error. If you omit the specific type of exception, Python will catch all exceptions inheriting from the exception class. Let's remove this 0 division error and see what happens. Run the program again. We have the same result. It is advisable to avoid this practice whenever possible. Another way to do it is to mention the exception class, exception. Let's run the program again. It works. We can also say except exception as e, which is a new variable we can use inside the except block. Error. Now let's execute the program again. 0 division error. The error is captured as variable e, which is then used in this block. This table displays the most commonly encountered errors. For more errors, you can use this command to check. In some situations, we might want to run a certain block of code if the code block inside try runs without any errors. In such cases, you can use the optional else keyword with the try keyword. Line 26 will run only if there is no error in the try block. Let's execute this program to see what happens. 20 divided by 5 is 4.0. Now let's try to divide by 0. Let's run the program again. You cannot divide by 0. The finally block is executed regardless of whether an exception occurs. It is optional and each try block can have only one associated finally block. It is useful in cleaning up resources such as closing files and database connections. On line 30, we opened a file without specifying the mode. The default mode whenever the mode is not specified is read. Line 33 will raise an unsupported operation because we are trying to write to a file when the mode is read. The closed attribute of the file object tells whether a file has been closed or not. Let's execute the program. This shows that this file was opened but was not closed. The finally block is a good place to perform cleanup operations because it will always run. Let's close the file in the finally block. Let's run the program again. Great, the file has been closed. The raise keyword allows you to force a specified exception to occur. It allows you to interrupt the program based on your requirements. Building on a previous example, we can choose to raise a value error to prevent a situation that could cause the program to fail. If y equals 0, raise value error. We can then put an optional message here: division by 0 is not allowed. Let's execute the program. Value error, division by 0 not allowed. It is important to raise the suitable exception based on the requirement. For example, using file not found error might not be the most appropriate choice in this context. The preceding examples only utilize a single except block following the try block. This example demonstrates how to use multiple except blocks to handle various types of errors. If the denominator is 0, this except block would handle the exception. For a type error, another except block takes care of it. Let's set the value of y to be 0 and see what happens. Division by 0 error. This block handles it. Now let's make y to be a string data type. Let's run the program again to see the output. Type error, unsupported operand types for division, int and string. We are getting this error because we are trying to perform a division operation between an integer and a string data type. X is an integer while y is a string data type. So it is impossible to perform a division operation between the two data types. Using a tuple of exception types is a simple way to catch multiple exceptions in a single except block. When an exception occurs in the try block, Python checks if the exception is any of the listed types in the tuple. If so, the corresponding except block is executed. Now let's execute this program to see what happens. 0 division error is captured by this block when the denominator is 0. Now let's try to use a string data type. Let's execute the program again. Unsupported operand types. Both 0 division error and type error are captured by this block. If you enjoyed this video, please give it a like and subscribe. Thanks.